all things data science. I'm Ivo, I'm a country manager from talent.io. Used to be an engineer myself before I went off into the recruiting business. talent.io is a recruiting platform where we try to connect companies and engineers that look for jobs on the platform. And we qualify both sides and make sure that we have the right people on the platform that are actively looking and hiring. We qualify everyone here, and then the companies apply the engineers, putting out the offer, putting out why they want someone to have them on board on the team. It's really important. Our main goal is to have a synchronized application process. So it's usually a hassle as an engineer to find a job and maybe apply to 3 different companies, and it takes one company 3 days and the other one 3 weeks to get back to you. So you can never really decide on what is the best product, team, and company to go for. And this is what we kind of try to fix. We're going to do this on a European level as a kind of marketplace. So much about us. I'm pretty happy to have the 3 people from the local community in Berlin here with different backgrounds. I mean, from my previous company background as well as now with talent.io, we're going to do a lot of community reach out and try to give back and like organizing these kind of events. So we have here Shermin from the Blockchainhub, who's going to talk a bit more about blockchain. Then we have Igor from Fyber, who's the head of data science there, and Josie, who's running the data science retreat here in Berlin. And we're going to have like 10 minutes each, a quick introduction about like their view on the current situation and what's going on in the topic, and then afterwards. So,
okay, so hi everyone. I'm going to get the tech going. Who here has heard of blockchain? I know this. Yeah. So who has never heard of blockchain before? And who could actually explain what blockchain is? Who really understands what it is? Okay. So I'm going to try and give a general overview. We don't have too much time. But, overview on blockchain. So the idea is a super short introduction in blockchain, smart contracts, and Web3. So would you like, because I heard you talk a lot, to put it in your own words, how would you describe blockchain?
Well, I actually like that explanation. It's like an Excel, it's like a spreadsheet in the sky. So it's like an Excel spreadsheet that's stored on everyone's computers, and you can add rows, but you can't change any row that was already added.
Okay, yeah, I think that's a quite interesting explanation. So basically, blockchain is this giant ledger of transactions, every node in the network has the same application state. It's open source. The blockchain protocol is open source. Every node in the network has the same information, and when transactions run through the network, they're verified by the network, and when the majority of the network says, yes, the transaction is valid, it goes through, and once a batch of transactions go through, a block is created and put on top of the chain, on top of the chain of blocks that were created before. So this is why we call it the blockchain. That's explanation in the nutshell, what it actually means in the context of computing, in the context of the history of the internet, and in how it works. I will try to give a very, very quick and brief overview. Give me a heads up, 3 minutes into running out of time. So in the context of the history of the internet, if we look at the internet, how it started, sorry about it. The PDF version. Just quickly, otherwise, just go ahead. So, history of the internet. The World Wide Web basically revolutionized information in the 90s. The Web 2.0 wasn't so much of a technical revolution, but it was more the application revolution. It was the rise of the consumer. We had all the peer-to-peer marketplaces on one hand, and on the other hand, we had all the social media where everybody was communicating with everybody at the same time. And it was a total disrupt, but so-called peer-to-peer peer-to-peer solutions always have the middleman, and the middleman is getting bigger, and more powerful. And the next step, and this is why we're here today, is the decentralized web. It's these technologies that will help us get rid of the middleman, one of them being the blockchain. And in order to understand the future of the internet, the future of computing, we need to understand how it all started. It started with these huge, giant computers in the 60s. Eventually, the computers became smaller, and more people could afford them all over the world. But in the end of the 80s, and beginning of the 90s, even though many people had computers, most of these computers were not connected, and that's very important. We had the ARPANET, we had the internet, but up until the late 80s, the computers were not connected. Until the beginning of the 90s, when people had computers, and email was the first clear application that revolutionized communication, and the World Wide Web revolutionized information. And more devices were connected, but in this traditional client-server way, where, yes, we're all connected, but data is still stored centrally. And it used to be on the devices like this, the touch pad, eventually a floppy disk, a lot smaller. Data is stored locally on the different devices. Data is stored in the cloud, but still it's centrally stored. And why is that important? Because we have questions of data security, transaction verification, it has to be central, and the questions of who owns the data in this world of centralized data storage. So the blockchain comes here, and I would like to explain the blockchain as it's kind of this decentralized operating system running on a decentralized network or a distributed network of computers. And the economists call the blockchain the trust machine because what it does, this protocol, this blockchain protocol, allows us to decentralize trust. And it's kind of, think of it as a layer on top of the internet. We have the internet, and then there is this other network of computers running this blockchain protocol, and it's this layer on top of the internet that allows us to have peer-to-peer value exchange, true peer-to-peer value exchange without the middleman. So basically, it's having a book, second-hand exchanges without eBay, flag sharing without Airbnb, without Uber. So basically, the world we're coming from is decentralized data storage. It keeps being a data monarchy, and the blockchain is data democracy. This decentralized network of computers is verifying each single transaction. What does it mean? If one node in the network fails, the system will still work. And I think that's very important. Here, in this decentralized system, if one or maybe even two nodes fail out of hundreds, the system will still work. The problem with the information monarchy, when the server fails, I have firewalls and I have backups, but when the server fails or when it's manually corrupted, the whole system fails. So technically, so we don't have time to get into true tech questions, but in order to give you a brief overview, it's basically a combination of three technologies that have existed for a while. Peer-to-peer networks, combined with the theoretical aspects to incentivize the different nodes in the network to verify the transaction and cryptography. And cryptography is used for privacy on one hand, as well as transparency. But the whole point of this blockchain is to create and run decentralized applications on top of it that have embedded smart contracts. That is the whole, like blockchain really is just like a protocol like TCP/IP, it's just an infrastructure. The network of computers is this decentralized world computer, and the protocol is the operating system. And the whole point to have this is that we can start building decentralized applications, that we can start programming smart contracts that are auto-enforceable. Now, what does that mean? A smart contract can be seen as like this kind of digital handshake And it's like this line of code where the rules of the game are pre-programmed into the contract. Just like the chessboard manager will verify, you define the rules of the chess beforehand, everybody knows the rules, and the chessboard manager could be seen like a smart contract who will verify that your transactions or that your moves are right. And so, as opposed to the world we come from, where transactions, where contracts are produced in paper and signed by hand, smart contracts are lines of code. They're signed with a private key, which probably much more looks like this. The whole idea of a smart contract is not new, but it's much more sophisticated on the blockchain. So you can see this machine as a kind of smart contract. The rules of the game are pre-programmed into the vending machine. If you put enough money when you select a certain number, the machine will give you the product, and if not, you won't get the product. And the game theoretical aspect is also very interesting. It's highly disincentivized to break into the machine because the value you get out of the machine is disproportionate to the fines you would have to get to break into this machine. So unless no rational human person would ever break into this machine, because 2 euros versus several thousand euros over jail doesn't make any sense. So basically, blockchain is this protocol where we can now play around and program all these smart contracts on top of it. And we're seeing the first ones happening, and it's very exciting. So who knows, who can tell me a smart contract or a blockchain application?
Serial?
Everybody doesn't use blockchain. Online blockchain can happen on the blockchain. Okay, so, well, Bitcoin, have you heard of Bitcoin? So Bitcoin basically more or less was the first blockchain. I will get into that. And the whole idea of Bitcoin in 2008, when Bitcoin happened, what happened? We had this huge financial crisis, and one thing became obvious, that banks are this trusted third party, but also this unique point of failure. When banks fail, the collateral damage is very big. So Satoshi came up with this protocol for Bitcoin, saying that how could we have money without banks? How can we have financial transactions without banks? And how much? So the big word here is disintermediation. As I said, the first mistake was Bitcoin. So the idea of, and the protocol behind Bitcoin was what we call the blockchain. And a few years into Bitcoin, we realized that you could take this logic and do many other things with it. And the vision is to have money without banks, like your Bitcoin, companies without managers, maybe you have heard of it, the DAO, and countries without politicians. It's very revolutionary in its sense, and many things are not happening yet, but many things are. And people always ask, what blockchains are there? So Bitcoin was the first blockchain in this form, where Bitcoin was what made the blockchain really big. And since Bitcoin was open source, you could take the protocol and fork it. And many thousands of altcoins have happened since 2008. And a few of the most interesting things that happened in this altcoin sphere was when people started to play around with the protocol and say that, okay, we could take Bitcoin as a token of transaction and build any kind of auto-enforceable smart contract into it, or use it as this token of transactions. And so there was colored coins and master coins, two of the altcoins that were very successfully trying to do that. But the founder of Ethereum, who was also working on one of these projects, he realized very early on that this is not very efficient. So he started building Ethereum, which is another public blockchain. And the idea of Ethereum is to take the idea of the blockchain, but to make it Turing complete, where you can now, just like a smartphone, where you can that has an operating system, and you can install any kind of application on your smartphone. Ethereum tries to be that decentralized giant smartphone for the world. So it's this universal world computer, and the protocol allows you to build decentralized applications on top of it. And I would say this is one of the most sexiest projects on the planet right now. So Ethereum. Many of you probably have heard of blockchains because it has been in the press. And because fintech is pushing that term, but when financial technology is talking about blockchain, or when the big companies are talking about it, they usually are not talking about public blockchains like Bitcoin or Ethereum. They're talking about kind of consortium blockchains or private blockchains, which have more elements of distributed database. Just to be aware that there are two different terms used, or one word used for two actually very different things: public blockchains and distributed databases. So we're coming to an end here. If you remember in the beginning, I was saying the Web3. So the decentralized web on the blockchain, it's just this giant ledger of transactions. You won't be able to save data on top of it. So we have a lot of really interesting protocols happening here. IPFS, Interplanetary File System. Swarm is the native file system of Ethereum. Whisper for decentralized messaging. Solidity is a DApp programming language that you would need on top of Ethereum. So we have a lot of social linked data is also a topic that is very, very important when it comes to owning your own data in your wallet. And so I think that we're in the very, very early stages of the Web3. And the future is decentralized. And I think somebody once said, it's like 1990s for the internet. And I think for blockchain and the decentralized web, we're in a very similar stage. We saw the first killer application is Bitcoin. And a few new things coming. Nobody really knows what's going to happen, but I think it's quite sure that the future will be much more decentralized than it is today. And we will have less client-server architecture and more decentralized architecture. But we will see in the next 2 or 3 years how this whole thing will pan out. It's hard to tell the future exactly, but I'm quite confident that we will be more decentralized. So if you're interested to know more, there will be a Q&A later, and I will be here. But check out our website, follow us on Twitter or Facebook, because this thing is fast evolving, and whatever is on our website is also is already out of date. We have 5 to 10 posts every day because much is happening. So follow us. Thank you.
Josh is gonna take over. Yeah, just gonna keep the door open.
So we talk about learning difficult things, learning non-trivial stuff. I'm sure everybody here has done that to a certain extent at some point. So this is about machine learning, but Ivo told me to talk about this machine learning, but I think it's actually wider than that. So I think we are in a very interesting situation in that if you want to learn a new technology, we are sort of on the run because companies assume that we're not going to be with them for longer than 2 years, so it's totally not worth it for them to invest in training the people. Because, okay, if there's a person who goes out of the door in less than 2 years, what's the point? So then it looks like if you want to learn something really hard, you have to do it really wrong. And that is kind of interesting. because people don't want to spend the weekends learning hard stuff with the So I think that's kind of the problem that is behind all this. But okay, one thing that many of you may have considered hard is machine learning. So who here is a programmer to start with? Okay. And who here would love to know machine learning? Okay. That's a lot more people than the previous group, right? Okay. So then you have to do something, and the good news is that there are plenty of MOOCs, there are plenty of places you can go, free books, very well blog posts by people working for super cool technology companies that actually share what they're doing. Very interesting time to be alive. But you have to put in the time somehow. And it's not working all that great. I don't know that many people who just attending MOOCs or just browsing blog posts got to a level where they are doing stuff that is serious. And I'm not sure why that is. But okay, so everybody seems to agree that you want to learn machine learning, that is an interesting thing. But what is it? So it is a pretty homemade definition. So you're basically building machines that don't need to know what to do. They just learn from data what to do. It's a very general definition. It's not a textbook definition. It's totally a fluffy one, so this is just something homemade. And why I think that this is important, I think that everybody in this room in 5 years' time will be involved in either deploying machine learning models or doing something significant supporting those machine learning models that the company that you're with is working with. Right. So if you look at what pitches go through the offices of VCs, so one thing that will happen if this thing that I'm talking about, that in 5 years' time we're all learning as if it was a school business, it's totally normal. The alternative to that is that you get this black art that some people know. These are some of machine learning that live in the mountain, and the rest of humans don't know anything about. And that's not a future where I want to be part of. So I want to help the most people that I can to get comfortable with machine learning. Okay, who here is thinking about doing a startup, or is already in a startup, or doing something with? So tell me if you have experience with something like this. So in the 90s, the pitches to VCs were something like, this is like X, but on the web. In the 90s, if you could write HTML, you could make a lot of money. And then in the notice, it was more like, well, it's like X, but social. And this really solved, and this will help you raise money. Now, in the sometimes we go to, well, we go to the VCs and say, this is like X, but mobile. And I think what's happening right now is that people go to VCs and say, this is like X, but machine learning. So this is why so many people want to learn machine learning, want to do something with machine learning. So one more reason to pay attention to this. But there's more to it. So some pretty serious people say the software is in the wall, everybody knows this one. But I think what's coming is the machine learning is software. So most of the activities that you do with software could be done better with machine learning. And in fact, you are already experiencing that. For example, you don't have a spam problem anymore, right? You just don't care about the spam ever. So this is a solved problem now, thanks to machine learning. It's been solved for like 10 years. There are plenty of other things. So the taxi driver that brought me here will not find this thing. This place at the house. We just didn't know how to get here, and I was showing him the map and pointing at how to get here. I think this is going to be the 5 years time that I'm talking about. So humans are actually not better than machines at some things that we consider impossible 10 years ago. One of them is driving. That one is still like, the jury is still out. It may be that machines are not better than humans at driving. Who knows? We'll see. But object recognition. It's a totally solved problem. You will see soon. Right. So do you know him? Andrew, the founder of Quesada. Something very interesting happened with him. He's now at Baidu in China. It used to be the case that all the smart people flew to the US and stayed there forever. And now it's kind of getting decentralized. So people who can do really interesting stuff are not necessarily in the US anymore, but the majority are still there. But here is a total thought leader that is in China and doing kick-ass stuff in a company that you may not have heard of 5 years ago. And he is saying that most of the projects that he's dealing with, is hundreds of projects, they are not designed to make more money for Baidu, they're designed to get more data. So when companies at this level are thinking about how to get more data and get better with data, that's a totally different way of approaching things. So companies in Europe are not thinking about these things. I can tell you because I have to talk to them all the time. I think this is a big problem. So if we don't wake up in Europe, we're going to get eaten up by not only the US but also China. So this is something that worries me, and I founded my company sort of to help Europe not fall behind more than it already is. Because if we do anything in 10 years' time, they're going to be as interesting to work for as the north of Africa. So let me click here. Okay, so this is a video of what can be done right now with object recognition in a shitty laptop. So this is not a highly optimized cluster of NVIDIA GPUs running deep nets. This is one person running an algorithm on his laptop or walking around the street in Amsterdam. And you can see that the machine is coming up with some crazy stuff sometimes. It was recognizing something on a graffiti that sounds kind of silly. The contrast is not so great, so sorry about that. But this is a pretty non-optimized machine learning algorithm doing object recognition. And it's not bad at all. And this is laptop is for running JavaScript. So the state of the art is far better than this. So if you can do that today, walk around with a laptop and recognize all the objects, things have changed. So computers can see. Computers can now say that this is a car, this is a boat, parking meter, so it's kind of good. So this was not possible 4 years ago. And this is what everyone is talking about, like, oh, strong AI is coming, we are going to be obsolete. This is what the taxi driver who brought me here should be fearful of. So this is the kind of stuff that I hope we are all going to be involved with in 5 years' time. Right, so what I do is I run data science repair. So what we do is to fly people from all over the world, keep them here in Berlin for 3 months, bring the best experts in topics that they are interested in that we can find, and let them basically learn as much as they can. So this is why I was talking about learning non-trivial stuff before, because when I started thinking like, how can I become a better programmer faster? And then I looked online and found something called Hacker Retreat. Sorry, it was called Hacker School. So it was a group of people that self-organized to just be together in the same room and be better by just sharing projects and so on. Right? There was no instruction, totally unsupervised, and they got people like the chief data scientist of Google, to come and work with them. So it was super cool, and as soon as I saw that, I thought, well, I want to be there. But then I looked to the left and I see my dog, I look to my right, I see my girlfriend with a child, and then it's like, I'm not going to be able to be in New York. So then I tried to do the same thing here in Berlin. It was called Hacker Retreat, and that thing failed. I think it was because there was no common goal for people going there. So people were working in different languages, they collaborate. The experts that we got from all over the world were not really helping them much. And then somebody out of the web sent me an email like, hey, you guys are all pretty good at machine learning, so why don't you do a version of Hacker Retreat that is about data science machine learning? I said, you're onto something. So then the main difference between Hacker Retreat and data science retreat, why data science retreat works and Hacker Retreat didn't, is that here there is a curriculum. People are working on only 1 or 2 languages that are approved, and they have to present to companies at the end, so they can work with a goal in mind. And this is working pretty well, so it's been running for 3 years now. We're running the 7th batch. This coming Friday, they are presenting to companies. And normally when companies hire these guys, they are very happy. One company told me the other day that the guy they hired fixed a bug in the first week that affected the entire company. So that's the very value of our company. And the people who come from literally all over the world, they are also very satisfied with what they get. So we run 200 interviews for each batch of 3 months, and assess between 5 and 10 people. So it's really hard to get in. And people who come in are not the typical bootcamp people that you may imagine, oh, this is a barista to raise monkey kind of bootcamp. So people who come here may have a PhD in MIT or be super advanced at some topic. So it's kind of very different from a normal bootcamp. So what I see, and this is where I was talking about how it is difficult to get good at something. What I see is that there is a bunch of people here, and this is about data science. These are the people who have done a bootcamp or 2 or not a bootcamp, and they know how to feed random forest, but they cannot really be effective. And then there's something like on the valley of death. There is a bunch of people here who are really good. They have the intellects guys who can change a company. So how do you get from here to here? I don't know. I think people are sort of going through this to get there. I don't know if they're succeeding. But this is a real problem, and I see this happening not only in machine learning but in other fields. So this is an example of a portfolio project. One of these things that people present to companies at the end. So this is a smart detector. So Stefan presented this. So you can see that there's a little green bar here. The more he smiles, the bigger the bar goes, right? So this works with any number of faces and so on. So one of the companies who was at that hiring day told him, are you stupid? Why do you want a job? Just do the stuff and keep it. He's actually here in Berlin with Distr doing fake smile recognition and also the reaction of people to advertisements. So if you have a camera looking at you, the advertisers can see how much people like the ad because of this. So this is what I have. So this is what we're doing. And if you have, if you're in this situation that you're trying to teach yourself something non-trivial, it doesn't have to be machine learning. Talk to me because I really want to solve this problem and to make progress any way I can. And I think we have to do something because companies are not going to spend any money on us ourselves. And if you don't want to do it alone, which most people will try but don't get that far, I think there must be some hack that we go do. And I don't know what it is exactly, but I want to talk to people who are thinking of this.
Cool. Yeah, and excellent.
I want to talk probably more generic about data science, not like some particular applications, some particular things, but in general, like what is the history of data science, what is data science, as I see, who are these data scientists, or again, as I understand them, and probably also about companies who are hiring data scientists, and probably about future, some future. So let's start with history of data science. So myself, I was exposed to data science somewhere in 2011 when I was attending Startup World Conference, and there it's not the time when I, for the first time, heard this word, but at least I met there a few guys who were claiming we're data scientists. So I was talking to them, and I really started understanding that really I'm probably quite a good fit for data scientists. Why? Because I have my mathematical background, I was doing development and especially in the last time architecture. And through architecture, I was quite exposed to different kind of business problems. So in this respect, I was okay with starting going into data science, and I, in parallel with my day-by-day job of architect, I was starting doing some data science projects, small, bigger, and different things else. Again, what is data science? There are a lot of definitions. I don't know, but at least for me, I have some kind of approach, quite simple one, at least again as I see it. So you've probably seen or not very famous Gartner chart about analytics or value of analytics. So it's starting with descriptive analytics, then it's going to diagnostic analytics, then it's coming to predictive analytics, and the best value and the most value is sitting in prescriptive analytics. Now what we're talking about. Let's say analytics as we understand it, or recently, it's not recently, but now 20 years ago, it's now called business intelligence. So we were doing business intelligence from the beginning of computers. That is one of the good things that computer can do. Calculate something and produce some data. And that is what is so-called descriptive analytics. So as business intelligence, we produced a lot of charts, a lot of tables, and based on these tables, some pivotal tables, some summarizing, and spreadsheets and all other things, and based on this, some guys can make a decision. But realistically, to be honest, they cannot make a decision, because it's too much data, and it's not really processed. Yes, you look at table, and you see something like 100 lines of data. Or you look at chart, and you don't understand what this chart is about. So it was always the difficult stuff, actually, to make decisions based on descriptive analytics. Sometimes BI department will get some request, ad hoc request. Guys, something happened, can you do something and tell us what was happening? Or let's say, we had a problem, can you estimate the amount of lost revenue? So this is what I would see as the diagnostic analysis. Again, it's usually some kind of estimation, some kind of data marking, and after that, something like produce, okay, we lost on this $2 million. Fine, great. And then there was always in data in business analytics or in business intelligence, always attempt to predict something. But prediction there is usually very simple. It's like, I have a chart, I put a trend line, probably not linear, probably something like square line, but usually it's just linear line, and I can predict the sales tomorrow. What is really happening is that data science is really starting occupying and doing the other analytics. This is predictive and prescriptive analytics. And what is predictive analytics in terms of data science? Probably the example will give you the most understanding of what's happening there. So let's say in our case, there is a general wisdom in mobile advertisement that revenue of application is based on daily active users. So everybody is, because it's quite simple stuff, you coming to some owner of application asking, okay, how many daily active users you have, let's say 10,000, then you can evaluate the value of this application. But realistically, it's not. And we did this research in our company and found that there is no correlation realistically. We're not talking about causation, we're talking just about correlation. So there is no correlation between daily active users and revenue of application. Why? Because realistically it's very long funnel, starting from request from application to show advertisement to this user, and actually finishing in conversions. How many conversions? What kind of advertisement was shown? How much publisher is getting for this particular advertisement when it's converted? And what we did, we actually break this funnel in many, many parts. We implemented for each of these parts different kind of simple regression analysis, and then we could predict realistically, which means that we're not only telling, okay, you have this number of daily active users, you have this application of this type, if you do things right, then at the end of the day, you will be getting so much money every day with this certainty. So we will not tell you that you will get 10,000. We will tell them, okay, you will get between 9 and 11,000. And that is where the power of data science is coming compared to business intelligence. But that is, I would say, simple stuff. Okay, you can help business, for example, to acquire new users and new customers. But realistically, the real power of data science happening further in this chain of value of analytics, in prescriptive analytics. Again, the simple example of prescriptive analytics is where the human being is still participating in decision. The simple stuff is any kind of recommended system. So you're seeing few recommended items and you picking up one of them. So you are the human being making the last decision. Or another example is fraud detection, not fraud prevention, but fraud detection. So let's say that you have some kind of data, and then algorithm or machine, software, I did implementation of such stuff for my previous company, so it can actually find out in the millions of transactions per second who is potential fraudster. It's actually not potential fraudster, it's outliers. But then guys from fraud department can come, so guys, fraud investigators, and they can look at this and say, yeah, that's really not just outliers, it's actually a fraudster. And by this, they can enhance their own understanding, they can add their rules and all other things. But that is still human beings, and that is still much more efficiently than it was before, because you have now less choices. But it's not so efficient that, or it's not the efficiency that we really need. And what we really need is where machine, where algorithm is making decisions. And that is where everything is going on now. So in any kind of trading system, any advertisement system, online system, everywhere is algorithm deciding what to show. And again, if we're talking about fraud prevention system, that is again, it's not the person who can decide, okay, I need to fight this fraud. It's actually machine is deciding, this is a fraud, and I have to eliminate it. And that is where the whole data science is sitting. Now, as we're talking about data science, probably it's time to talk about people who are doing this data science. So data science, who are they? Again, there is a general wisdom at this moment that data scientist is some kind of 3 areas of knowledge. So it's science, probably mostly science, it could be mathematics, but science is good enough here. Then it is hacker, how sometimes we're calling this, but realistically it's just developer. And then there is a business person who is understanding the business of things where data science will be implemented. It was at some time that we were thinking, okay, this is the data scientist, but they are really some kind of unicorn. It's very difficult to find some kind of this person. And it's very difficult to teach them. But then it was something like, okay, guys, we can make groups where there are some guys who are doing development, some guys who are doing science, and some guys who are doing business process. But what is really happening, and again, it's coming from my experience, that the best thing is to start with science. Because the whole data science is not just science, it's really science, because the whole approach is really scientific. You're looking for some hypothesis, how to solve the problem. You're then doing some experiments or testing. And then you really can say, okay, this algorithm is working. Plus, on top of this, you probably need not only to find that algorithm, but you also need to tweak it. Or in some cases, you even need to invent an algorithm. So the scientific background is really what is most important, at least for me, when I'm hiring somebody, so that if you really don't have proper experience with data science, then it's okay if you have science experience plus some programmatic skills like working with R or with Scala or with Python, with some languages. And then you can really teach a person to be good in business part of, again, industry where you're working. And then definitely you need to improve your skills, but programming skills. But that is again not a problem because at this moment there are very well-defined set of languages that you need to get, so it's not a big problem. Now, as you can see, it's very difficult to hire data scientists. So we're usually going for compromise and hiring some kind of scientist and then teaching them data science. What is even more difficult is to find company where to go as a data scientist. Why? Because a lot of companies are now claiming that we are data-driven. We are doing data science. We are doing data products. But if you look at this company, then there are two very distinctive cases where you should not really go. The first case is that they don't have data scientists at all. So you will be the first data scientist in this company. And usually they will say, okay, you are data scientist, but probably you are not great, so we will take you as a junior data scientist. And you will be there only one trying to solve their big problems. Do some magic with data science. That's never good. Because as a data scientist, you really need to talk to other people. And this is not just going to meet up with somewhere else or over email. It's really where you need to bounce your ideas every day or every half a minute sometimes. Because you're getting some new feelings, you need to talk to somebody. So this is then one type of company. So they're expecting from you a lot, giving you nothing, and they have another big problem. So don't go as a first data scientist in company. The other problem, the other type of company, where company is big enough, so they're saying, okay, we already have data science department, or you will come there as a first data scientist, but we will hire another 2 or 3 other data scientists. But what you will find in such companies that realistically there is no appetite for implementing data science. What I mean? Usually this company, they have already established product. And this product is usually not suitable to put into it any kind of algorithms or proper frameworks to develop algorithms or to use any kind of machine learning stuff, again, algorithms and other things. So, usually it's a problem of management. It's not a problem of a company itself. Again, the problem of management is always a problem of company. But in this case, it's again quite easy to understand, is it the right company to join or not? So if they already have few data science guys, you need to talk to them and figure out what is their daily routine, or let's say the cycle of what they are doing. Because in reality, there should be the standard approach is that there is a business problem. So you are looking at a business problem, you are looking at a project sponsored by business. So you are not inventing some kind of problems or inventing what you will be doing, but there is really a business problem there. And then there is a way to solve this problem. There is a research part where, or research phase where you try different algorithms. And then there is already established framework how to implement what you will find. So if it is not in place, then you will be again struggling with a lot of things, and most likely will be frustrated. So the last it's time to finish. So the last is very simple. Future. Future is very simple. I believe that our future in terms of software development is really artificial intelligence. Again, how we build it, how we think about artificial intelligence. But what I believe strongly is that data science and data scientists will be probably the driving part of developing artificial intelligence. That's probably it.
Great, thank you very much. I would love to invite you all to the front.